Hey guys, it's Miss Willis here. We're going to be looking at the um, structures of the respiratory system today. So let's get started. Um, you can pause and read this if you want. Start here in the upper tract. So when you talk about like having an upper respiratory infection versus having a lower respiratory infection, we're starting here in the upper tract. So looking at our nose, obviously that's an area where air can come into the respiratory system. Within our nose, we have the nose hairs, which will trap any dust that enters in. I don't know if you guys remember from Osmosis Jones when they're in like the little helicopters, and when pollen comes in, they're trying to like shoot at the pollen so that it didn't get any further. They were supposed to be kind of the team along the hairs. But if you actually look at nose hairs and how they're all intertwined with each other, it just increases surface area to prevent any of that stuff that we don't want coming into our body from getting any further in through such a vulnerable opening. Your nasal cavities, they are lined with mucus, and then they're woven around we have our nasal concha as well. We're going to see that in a picture coming up here. But it's all the bone contouring within your nose to just, again, increase surface area. With that mucus layer, and there's going to be a bunch of blood capillaries that are really close to the surface in here. This helps with moistening the air as it comes into your body. So if you've ever noticed, if it's really cold outside, you breathe in through your nose rather than through your mouth, because if you breathe in through your nose, it's more likely for the air to get warmer and be more moist, versus if you just breathe in through your mouth, cold air is just hitting straight at the back of your throat and it kind of burns after a while. We have cilia covering the membrane, and those will all be here, and they will push the mucus and anything that it traps, it'll push it down, and that's when you have a runny nose. Or it'll, if it's at the very back, then it's going to push it to your throat so that then you'll swallow it, or that's when people will spit it out and huck a loogie. So it just depends on how far back we are. But here you see the nasal concha. You see that it's shiny, which would show to us that it's moist. It's also very red, which would be showing us the capillaries that are so close to the surface. Those capillaries being close to the surface are what help warm the air as it comes through. People who have nosebleeds tend to have brittle capillaries in this area, and so as that cold air comes over them, it causes them to crack and bleed. When we look in here, we see that we have the sinuses. The sinuses are continuous to the nasal cavity, and they are in the skull to help lighten the weight of the skull. Our bones are very heavy, and so if we have these spaces, it can help with just kind of lightening that weight. They also can become infected. Then you have a sinus infection. You can get bacteria or something, inflamed tissue within there can cause a lot of pain and irritation. Sinuses also play a role in the sound of your voice. If you've ever like plugged your nose and then you sound funny, or if you have stuffed sinuses, your voice sounds different. It kind of sounds nasally, or you know what I mean, like when it sounds like people are kind of stuffed up. It's that the vibrations aren't moving through your nose the way they normally would. Let me move this down and see if we can see more. Okay. So that inflammation is called sinusitis. And so anytime that those passages between the sinuses and your nasal cavity get blocked with mucus, or if the tissue becomes inflamed. Then getting to our pharynx, we have three parts of it: the nasopharynx, which is the part of your throat behind the nose, the oropharynx, which is the part of your throat behind your mouth, and then moving down here, the laryngopharynx, which is the lower part of your throat where your voice box is. Your larynx is your voice box. So let's see if all of this will pop up. Whereas the nostril, the nasal cavity, sorry, you can't see these words up here. Whereas the nostril, the nasal cavity, the pharynx, and the sinus. So as we reveal those, you can pause and try to find them. Not sure why those went out of order. Then we get into the lower tract of the respiratory system when we get to the larynx, which is your voice box, the la 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 larynx, versus very similar word, the pharynx, which is your throat. And that part of your, when we go back to talk about the pharynx, there's a part behind the nose, behind the mouth, and then just above your voice box. When you think about it, and you have been like swallowing a drink and you laugh and it burns the back of your nose, it's because all of that is continuous back there, and so it has shot up behind your nasal cavity into the nasopharynx. Then coming back here to the larynx, it is your voice box. Important for swallowing, coughing, vomiting. We have this part here, the hyoid bone. This has an attachment with your tongue and helps lift this up. We've talked about the epiglottis before. If we haven't, we're about to here in this unit and the next. Epiglottis is what's going to keep food from going into your voice box and into your lungs, and rather down into your esophagus behind all of this. The larynx and the thyroid cartilage, or Adam's apple. So right on here we have our thyroid, which we talked about in the endocrine system, and then there will be thyroid cartilage, which you can see here is an Adam's apple. Moving our way down, we have the glottis and the epiglottis. The glottis is the opening of the larynx that air is going to pass through. Epiglottis is going to be the flap of tissue that keeps food from going into your lungs, into your trachea, and all those things. So it's like a soup can. So here's the like the hole for your trachea and stuff. Okay, there's gonna be this little lid. When you breathe in, it opens up. But when you go to swallow food, it covers it so that food will slide down into the esophagus instead of going into your windpipe and into your lungs. So looking here, it closes like that soup can lid closing up so that food goes down into your esophagus rather than into your trachea. Vocal cords are, I can't play the video because of copyright issues with me posting this to YouTube, but your vocal cords are just flaps of tissue that as they vibrate quickly, it creates sound. And so you can Google this. Steven Tyler, The Incredible Human Machine is the name of the video that this comes from. I'll try to link it on Canvas if you want to take a look at it. It's a very quick clip, but if you know who Steven Tyler is, he's the singer for Aerosmith. They actually take a camera and look at his vocal cords, and he actually had an issue with his vocal cords where there was blood accumulating, and they take lasers and zap the little capillaries. It's actually really cool. It's not as gross as it sounds for those of you who are like, I don't know if I want to watch that. Then we get to the trachea. Notice these rings of the trachea. There is, let me move this down just a little bit. There is cartilage that holds the trachea open, and it is C-shaped. Where's my camera here? It's C-shaped. This would be the front. So say that the Adam's apple would be on this front side here. And then the esophagus is going to be behind it. And the reason that this is C-shaped instead of also being closed is so that if you swallow large food, as it expands, it's not going to pinch your trachea shut. It'll actually stay open. The other reason for needing the cartilage in the first place is so that the tube stays open all the time. We wouldn't want, like, if we turned our neck like this, we wouldn't want that to collapse shut, or we wouldn't be able to breathe. Imagine how many times you've fallen asleep like this and you would have stopped breathing if you didn't have those little cartilage rings to keep it open. So we've got the trachea. So moving down here, and then we're going to split into the right or the left lung. When we look in here, we can see that these rings come out this way. So this is actually the front side of the body, and then this side where the ring stops is going to be the back side. So that would mean that when we look at it, that this over here is the right lung and this over here is the left. This split right here is called the carina. And then it's actually more likely if somebody inhales something. There's an episode of Grey's Anatomy where a guy, I think he goes to swallow his girlfriend's key to try to keep her from running away, but he ends up inhaling it instead. You can correct me if I'm wrong. But anyway, it's more likely to find objects. If somebody accidentally inhales an object, it's more likely for it to be found in the right bronchus, this tube down here where it splits, than the left, simply because it is a steeper angle. This kind of flattens out a little bit more and this drops down. So something might stay lodged right here versus falls all the way down on this side. Continuing on, the bronchial tree is all of this that you see. It looks like an upside down tree, even with all its little branches and leaves. The bronchi are the first two branches. As those continue to break into smaller and smaller branches, those are called bronchioles, until we get to the very end where we have little grape-like sacs. Dang it, I'm trying to move this down. That are called the alveoli, and this is where the circulatory system and respiratory system touch. This is where they come together. Oh, I'm starting to run out of time. Lungs, we have our pleural membranes. This is what makes sure the lungs stay pressed up against the rib cage instead of collapsing. When you see in a movie that someone has a collapsed lung, they stab them so that it will suck back up against the wall of the rib cage. It's talking about those pleural membranes. So this is asking, where's the pleural membrane? Primary bronchus. You can pause and then find them. Okay, this is another one that you can pause and take a look at. I've only got 2 minutes left. Where is the bronchus, epiglottis, larynx, and trachea? Okay. Oh, we ended up having enough time. All right. Well, that'll be all for today. There is a little homework quiz to do over these notes, so make sure to do that. You can have a couple attempts at that and get your points for today. So I'll see you next time.